Hi, I'm Andy Warfield. I'm CTO and co-founder at Coho Data. And thanks for joining me for the second of my vBrownbag talks. This is a 10-minute format where I try and limit myself to saying lots of stuff in very little time, hopefully successfully. Already this is going better than yesterday because of the keynote being pushed out yesterday. I was competing with Maroon 5 playing in the background during the entire talk, and it was very distracting to try and get my message across. So anyways, yesterday I spent a bunch of time talking about a thing that I often talk about, which are the implications of trying to architect a storage system around really, really high performance memory. And today, I would like to explain to you why you shouldn't think about those things, right? If you're using a successful storage product, and so I've tried to come up with an appropriate title for this, and the title that I settled on is that your AFA is not a hot dog. And so, what on earth does that mean? So, I had this roommate in college who grew up on a farm. And he had a bit of a twang when he talked. He was a really great guy. And he loved this joke that he made every single time he saw someone eating a hot dog or we went to the grocery store. And he would say, "Those things are lips, hooves, and arsels." And it took me a little while to work out what an arsel was. But then I got it. And so the thing that got me thinking about hot dogs in the context of AFAs is that hot dogs are frequently billed as being 100% all beef, right? Or 100% all chicken or pork or whatever. And this 100% aspect, right? This supposed purity of the hot dog is something that I think is distracting. I think it's something that maybe invites you to think about something that's possibly not the most important thing. Hence the lips, hooves, and arsels, right? It's what parts of the meat are being used in the system. And so I wanted to kind of draw some distinctions between the language and the concerns around building flash-based storage systems today and the ones that we had when flash-based storage systems emerged, which wasn't really that long ago. It was only 5 or 10 years ago that we started building these systems. And so, the way that I think about the original round of all-flash storage or flash-based storage systems is much like the first cars that used electricity in any form, right? It's like the Toyota Prius sort of version of enterprise storage. Flash was a really, really sort of painful and weird medium to work with in building a storage system. The concerns with it were manifold. First of all, it was really expensive. Second of all, it was really expensive relative to its size, and its size was so small, right? The typical SSDs being very small relative to what you could buy in a hard disk, that it was actually hard to build a meaningfully sized storage system. And then there were all of the other things around Flash, like the fact that performance had a lot of volatility, right? Flash could go away for long periods of time. And there were concerns around the durability of it, right? That you might run out of durability on your array, that it would someday, stop absorbing new writes. And so the language that we built around constructing storage systems with this original round of Flash was all responses to this, right? It was, we have to do data reduction to make the thing plausible at all. We have to really worry about deduplication and compression and stuff like that, right? We have to worry about wear leveling so that we don't get to the end of the lifetime of Flash, right? It was tons and tons of stuff. And what you ended up with was an architecture that was basically the same as the existing spinning disk architectures that we've had forever, right? With a bunch of extra logic in it to deal with the sort of pain associated with working with Flash. Now, they were absolutely faster, especially for Seeks, but at the end of the day, the architecture was very, very similar to what we had before. Now, I think that it's maybe worthwhile going through each of those concerns one by one really quickly and talking about how they are different today. So let's start with the durability one, right? Durability is something that was such a believed problem with Flash systems that all of the vendors for drives over-rotated spectacularly in a response to, right? They went so crazy trying to deal with the two problems of durability and avoiding variance in access time that they over-engineered these things for the following 5 years. So today, when we go and buy an enterprise flash drive, generally, the variance in access under load or under age is almost nothing, especially if you go with one of the better vendors for them. And secondly, the drives are actually warranted for 5 to 10 complete drive rewrites per day for 5 years. And so hitting the end of durability is actually a pretty challenging thing to do. And we've had drives break in storage systems forever, right? We replaced them. So why was the durability problem a concern to begin with? So, that's one. The issues around cost are another one that I find really interesting, in that, a lot of the early language around dedupe and compression were sort of motivated by, trying to deal with these really small drives, right? Today, you see this huge stratification of the flash that you work with. You see PCIe flash, SSDs, flash moving onto the DIMM bus, right? Flash looks a lot like the hierarchy of cache on a processor. And a good storage system should be mixing those types of flash, right, to balance the economics of what a piece of flash costs with the performance capabilities of it. So, that's sort of a quick sketch of some of the ways that I think, systems shouldn't be talking about flash anymore, right? That these are problems that we've largely solved. Now, what should we be talking about? Well, I think, as a customer of an AFA or as a customer of a storage system, it's a really good idea to ask what the storage system is doing, right? Whether it's software-based or hardware-based or whatever, to make your life easier, right? If you are having to deal with traditional operational aspects of storage, right, that is the domain that a lot of newer storage entrants are really trying to tackle, right? If you're dealing with forklift upgrades, migrations, RAID characteristics, these types of things are things that are by and large going away, right? And so I'd love to have you come by the booth or watch some of my longer talks to see some of the ways that we deal with this stuff at Coho. I thought I'd just vignette one aspect of the system that we work with that I think is kind of interesting, and I've not talked about this in a lot of detail before, so it's sort of a fun one. We added support over the last 2 years to the product to not just phone home with random stats about latency and IOPS, right? These things that a lot of storage systems do today. We actually added support to sketch the working set of each application workload in the product. And so what we're able to do is to look at an app, right? Look at a VM or workload and understand the unique set of data that it's accessing over a period of time. And the reason that that's important is it allows you to effectively cost that workload, right? A database that is doing 1,000 operations a second over a gig of data, and a database that's doing 100,000 operations a second over that same gig of data is actually relatively similar in terms of its cost, right? Certainly at the level of the storage that it's sitting in, right? You need a bunch of fast storage. A database that's doing 1,000 operations a second over a terabyte is much more expensive to host in the system, right? You need the data and fast storage to sort of take that moderate rate of I/O, but you're using way more storage to do it. And so in the system, we added the support to characterize what are called miss ratio curves, right? To understand how well a workload will do subject to a certain amount of flash. And this is a sample of us working through with a customer characterizing a Splunk workload that's running on top of us. And these are two snapshots of Splunk running at different periods in time, right? So the first one characterizes Splunk after about a week of deployment. And what you see is this ingest and scan behavior. The data's all been written into Flash once, and it's all been accessed for indexing. So it's been accessed about once. And so the value of putting it in fast storage is almost linear, the blue line, right? The Flash that you have is sort of incrementally beneficial. The thing that you see in the longer term deployment is this sort of emergent, I got that backwards. The green line is the 1 week deployment, right? And in the 1 week deployment, you see no benefit, down here, in the first plateau because it's a linear scan of the data, right? You need enough to store the entire working set to be able to reaccess it for a win. And then you see a big data ingest and then another one of those properties, right? And over time, over 12 weeks, the data is actually accessed a bunch, right? And it's accessed in different pieces. And so you see this move to a sort of linear sort of responsiveness from Flash, because the more Flash you add for this specific workload, the more benefit that you get from working with it. A second example of this is modeling really, really painful workloads, right? And so this same customer actually phoned us up about a month ago and said that they were hitting the edge of tiering performance on their system. And so they wanted to understand what they could do, right? Should they buy more hardware? Should they adjust the systems that they were working with? And in that case, we were able to pull out the 10 or 20 VMs that had the biggest footprint, right, the biggest working set. And we gave them a list a day later based on that analysis, and they went through and they said, oh, this is weird. There's one VM here that I think suggests that your data is totally broken, right, because the VM seems to be accessing half a terabyte of data, but there's nothing on the disk, right? What's wrong? And as they poked into it, they started to realize that their backup agent was actually trying to figure out an incremental backup from this disk, but there was no file system, right? It didn't have the metadata that it needed to quickly scan for incrementals. So it was having to walk the entire disk every 6 hours to try and figure out what was going on, right? So this identified a really, really significant source of pain, right? This is the kind of diagnostic that your storage system should be providing you, right? This type of analytics within the system. So, we've got about 6 other kind of cool examples like this, and they're not all to do with really kind of weird-looking graphs, right? So come by the booth, and I'd be happy to tell you about some of the examples. The way that I sort of, like to think about this, who wouldn't, is relative to the Prius that I started with at the beginning of the talk, right? The model that we're after with taking advantage of Flash is that Flash is just a tool, right? It's just a tool in the same way that a battery or an onboard computer is a tool in an electric car, right? We should be doing over-the-air upgrades. We should be improving the system continuously on the customer site in response to a customer's concerns. And so I think that the model that Tesla has established with continuously improving their cars is one that is a good match for what we're trying to do on the storage side. So that's it. This is the last of my vBrownbag talks for this year. Thanks very much for tuning in. I'm giving a talk about some of the work that Coho's just announced around moving extensibility into the storage system by allowing containers to be run adjacent to data. That's this afternoon at 3:30, and please come and hear more about it there. Thanks a lot.